Well, I was just relaxing on my sofa, scrolling through my phone, just checking out some YouTube videos, and I had a notification come up for Chris Miller Cycling. Now, Chris Miller Cycling, he's another cycling reviewerist who lives on the east coast of Australia in Sydney, and he does some pretty good content, so go check him out. Now, for this particular video, he was doing a review on the new SFA power meter, crank-based type, and it uses a pod system that mounts onto the arms, which is very similar to some of the other brands, and it looked like a pretty good piece of kit, and it was actually very light. I only added something like about 20 grams to the weight of the crank. And then he started to move on to the accuracy, and then he claimed plus or minus 1%, which sounded really good compared to most of the power meters on the market, which normally claim plus or minus 1.5%. So in your mind, you're thinking, hey, this SFA power meter, geez, that's more accurate than most of the other power meters on the market. Well, that's when my BS meter went off. So let's roll that intro and let's have a bit of a discussion why quoting percentages and different percentages between different brands could really be completely meaningless. Now, before we jump in and talk about, a power meter is plus or minus 1% or it's plus or minus 1.5%, we need to understand how the system, the international system, works in the world for measurements. Now, to make sure that everywhere in the world is measuring the same thing, now that could be 1 kilogram, it could be 1 meter, it could be 1 watt, or it could be 1 Newton, right? So whatever that is, these labs maintain a device that is either calibrated or set up to be very accurate for that particular type of measurement. And then what happens is, if just say I've got a lab and I'm going to make some power meters and I'm going to test my power meters against a standard, say Newton meters, I send it off to that lab in that country, my standards lab in that country. I have it tested against their device that is a known device, and then I get it back to my lab. Then when I get my pedals, my cycling pedals, I can test them against my standard, and I know they're accurate. Now, when I've got my power meter in my lab and I'm going to test it, I test it at different points. So let's just say, for instance, the average human being can put out about 250 watts, and that's a pretty standard quote, and that's why most e-bike power assists are set to 250 watts. So what I would do is I would put pressure on my power meter, and then I compare it to my standard I have in my lab, and I go, hey, look, this one's reading 250, this one's reading 249. So then I would say that the error is minus 1 watt. To get the real reading. Okay, so that's pretty obvious, right? So what they call that is a correction. You can either give it the correction, so you add it to get the real error, or you can take it away to say it's the error. And then you would do that at different points. So I might do it at 250 watts, I might do it at 200 watts, 150 watts, 100 watts, 50 watts, 10 watts, 5 watts, or whatever. So I would decide how many points I'm going to test. Now, at those different points, I may get 1 watt variation at 250 watts, but at 10 watts, I might get 3 watts variation. At 400 watts, I might get 5 watts variation, because the accuracy may not be linear associated with the force applied to my power meter. And this is pretty normal with any measuring device. The error is generally not linear, and generally the biggest error is at the lowest force, because when you apply a very low force to a device, it's very hard for the device to turn that into an electrical signal and then calculate that as a wattage, because when you put your foot on a power meter, you're putting pressure on it, and then there's a device that measures that pressure and turns it into an electrical signal, and therefore then you get your reading, whatever it is. Now, when you actually have that measurement, let's just say it's 249 watts for the standard, 250 watts for your power meter. So we know that there's a 1 watt difference. Okay. Now, we also need to claim the ability of the lab to test. So when I get that 249, to 250, my lab, because my lab's not as good as the standards lab in the country, then I could have a bigger variance of error. So I might be able to measure down to 0.5 of a watt, say. So that's my resolution. I can only measure in 0.5 of a watt resolution. So I can say it's 249 watts, 249.5 watts, 250 watts. Anything in between, I need to say on my report plus or minus 0.5 watts, because I'm not really that good at testing. I'm not as good as the standards laboratory that has to control these standards in the country. And then what you also need to do, you need to do some modeling for what they call your standard deviation. Now, standard deviation means, if I do 1,000 tests, then 3 tests in that 1,000 will be outside of my ability of my lab, which is the 0.5 of a watt. Now, and I'm going pretty deep here, I hope you can follow. So when you actually quote a accuracy, you will give the actual correction or error of the device at that point. Then you will also give the variance of your lab, which is 0.5 watts, and then you would give your level of confidence, and we would say probably 3 sigma, which is 99.7% standard distribution. Okay, and that is how you're supposed to, on international standards, quote error. So when we get this percentage for power meters, really what a percentage means is the ability of the lab to test within that percentage. Okay, that's what it would mean if you was reading it on a report. Now, I would bet any money that these companies that are making these power meters for the cycling industry, they're not even doing a measurement. All they're doing is adding up the errors of the components they're using within the pedals, putting them in brackets, and then multiplying them by squared, and then dividing them by the number of items that they've used. And that gives you like a rough error. That's the really rough way of doing it. And they wouldn't even be actually really measuring them, because I can guarantee you at a lower end, the power meter error will be a lot worse than probably at the higher end. So if you're riding around 250 to 300 watts, you probably find the power meters are fairly accurate. Once they get down to 50, 40, 30, their accuracy would probably be very poor. And that's just the nature of how most items work that are in measure. It's the same with a scale. At the lower end, they usually have a bigger area, and at their main design weight, just say that'd be 1 kilo. Just say you had some scale for some meat, and most of the meat they're selling is around about 1 kilo. They would design the scales to be accurate mostly at 1 kilo. They're not going to make them accurate at 0.05 of a kilo, because not many people buy that much meat. They want to buy a kilo of meat. So the error at the lower end would be very inaccurate. But there would be regulations in countries for measuring food and so forth that would mean they have to stay within certain variances. Well, anyway, guys, I hope that explains it, and why when we get these power meters, they're not real. What they're stating really is pretty meaningless. And even when you have people like DC Rainmaker and GP Llama comparing them, yes, they're comparing one power meter to another, but the inherent errors of those power meters would be at the bottom end. So you're probably comparing something that could be very bad at 50 watts to something that's very bad at 50 watts, and they look very similar. Okay, we can say that they're consistent and repeatable, but if you're saying it's 50 watts, it may not actually be 50 watts. It could be 45 watts or 40 watts or 60 watts. And that is my issue. And the bicycle industry really should be quoting the items, I do believe, as per proper standards. And I would say that would be to be done at 250 watts. So when you receive your power meter, you'll have a calibration certificate in it, and it will say 250 watts, what the correction is or what the error is. And that would be a lot more meaningful to people, because then they could say, hey, look, when I'm riding, typically putting power out around about 250, 300 watts, I know this power meter is this much accurate. Well, to just make the whole matter worse, we have power meters that are just one-sided. Now, we have these things, they're still quoted at 1% or 1.5%, but we have an imbalance of power, because both our legs aren't the same. We generally have one foot that's stronger than the other. We may be left-handed or right-handed or whatever. So when we see that figure on our computer, we actually believe what it says. But in reality, it may actually be 20 watts out, because all it's doing is taking one leg and doubling it. So when we talk about this 1%, it's really completely meaningless in the real world. And plus also it's averaged over 3 seconds. So we really need to get back to, the bicycle industry really is selling us something that's not really that true. It's kind of true, but not really that true. Or it's kind of a near enough is good enough type of quotation, plus or minus this percentage. But really, it doesn't follow any industry guidelines. And this is my beef with the bicycle industry. If you work in engineering or you work in the medical system, there's certain processes and checks and balances in these industries, and you can't just go off and just do things, and say, oh yeah, look, this does this. I've done some testing at some university. I'm going to quote my accuracy this way because I don't like the way the industry does it, or it's too expensive to do it that way and I don't want to spend the money, and customers won't know any different. And this is why I'm calling it out, because there's only a few channels doing this, and we get a lot of flack. Channels that are calling out the bicycle industry get a hell of a lot of flack, and sometimes even their channels are taken down. And as I've said before, the bicycle industry needs to prove to us that their equipment does what it says to us. It's not for us knockers or whatever you want to call us, to have checks and balances while we're saying it's not true. If you go out there and do some research, it's not too hard to find that there is processes and systems throughout the world to standardize things. But the bicycle industry seems to think that they can go off and just do whatever they like. So guys, that's why I'm making this channel, and I'm just trying to bring to you guys out there a different voice to call out the cycling industry, so you guys are fully aware of what you're being sold. And hopefully, if there's enough pressure, the bicycle industry will change. And I think the way that they quote accuracies for these power meters is totally inappropriate. They should be following industry guidelines, and it actually wouldn't even be that hard to do. All they would need to do is give 1 point of accuracy, say at 250 watts for that meter, give a calibration certificate with the actual power meter, so it's been tested, and they could actually have a international standard report in there and traceable to their standards lab in their country. And that wouldn't be too hard to do. Well, anyway, guys, that's where I'm going to leave it. Thanks for watching. I'll see you next vid. Cheers.
Yeah.